Now, most people think that they know what an atom is. Most of the time, atoms are thought of as hard little spheres that make up everything that we see and touch. A slightly more sophisticated view is that there's a nucleus sat at the centre with electrons flying around, much like satellites flying around the Earth. Now, in one sense, this is correct. But the problem comes when you start to consider the relative scales of these parts. Then, the atom starts to look a lot more peculiar. Let's start with the world's, indeed the universe's, simplest atom, the hydrogen atom. At its centre there is a single proton, and around this orbits a single electron, and it's the orbit of the electron that gives the atom its size. Now, this is the sort of diagram that you see in most textbooks, in terms of the number of parts, their names, charges, etc. It's correct. However, these diagrams should have the words "not to scale" on them. Let me explain. To give you an idea of what a scale model of a hydrogen atom would look like, I'm going to need something to represent the proton. I'm going to use this miniature glitter ball. It has a radius of 3 centimetres. So at this scale, where's the electron going to be? 30 centimetres away? 60 centimetres? Maybe a metre? Actually, we're going to need some more space for this. So here's my nucleus. To give you an idea of how far out the electron would be, we're going to have to zoom out a bit. If the proton had a radius of 3 centimetres, then the distance to the electron, in other words the atomic radius of hydrogen, would be 1.87 kilometres. The atom is mostly empty space. In fact, 99.9999999999996% of the volume of the atom is made of absolutely nothing. I find that amazing. 99.9999999999996% of the volume of the hydrogen atom is nothing. That leads us to another weird property of atoms. If the vast majority of the atom is empty space, why do atoms have so much mass? The mass of a hydrogen atom is 1 relative atomic mass unit. However, the electron contributes only about 1/2000th of this mass. In other words, almost all the mass of the hydrogen atom is concentrated in the proton. And we have already seen that the proton occupies a very small volume in the atom. If we stay with our glitter ball as a scale model of the proton, this little ball should have a mass of almost 70 billion metric tons. No. My brain can't cope with that number either. What on earth does 70 billion metric tons look like? This is the Harmony of the Seas, one of the world's largest cruise liners. It can accommodate over 8,800 passengers and crew. You can get an idea of the scale of the ship from the person standing just under the name on the bow. To get the same mass as my glitter ball proton, we would need well over 500,000 of these ships. In other words, protons are very, very, very dense. So, atoms are mainly empty space. But what isn't empty space, i.e. the nucleus, is extraordinarily dense. These strange atoms make up you, me, and everything around us. And as chemists, we get to play with them and to rearrange them into new and exciting materials.